Hi, students. Let's go into the session of clever multiplication and division. It is the MetaForge Level 1 session on core tier. There's an upper tier of mastery on it. The core tier calculation module, the second time session. The theme is clever multiplication and division. Students, if you own the qualification here, you will learn a lot in this session. Otherwise, your learning efficiency is relatively lower. Okay. In United States K-12 system, if you good completion on grade 4 mathematics, that means you really understand the place value. You're familiar with multiplication table within 9 times 9. Okay, you understand the principle of vertical form of multiplication. Of course, division, vertical division law, you understand, and be able to apply it proficiently. Okay, you understand the mechanism, you use it well. Let's go into the examples with 5 issues. The first one, basic square number. Now, you have been familiar with square number on multiplication table. 1, 4, 9, 16, 12, 36, 49, 64, 81 are extra. But a strong familiar with the perfect square number up to 1000. That means the base is just up to 30 is very helpful. Greatly benefit to your future on the path of learning math. On the MathForge mathematics systems. Okay? On the path of learning number theory or learning advanced calculation module with algebraization of numerical computation method. A lot of benefit will happen in future. In India, the country commands students to here to master the multiplication table within 19 times 19. It's good, but a little further is essential on the MathForge system. Okay, let's begin. Square of 11. 1, 2, 1. 12. 1, 4, 4. 13. 169. 14. 196. The last two digits reversed. Okay. Here, 5225. We will start it a little later in this session. It's very interesting and very important. Yeah. Here, 256. 256. This number is very important. That means 8 twos times together, or call it 2 power 8. Okay. Is a very common, very important basic number in computer system. Okay. Computer scientific learning. Okay, that's the basic number. This one, 17. 289. Yeah. 18 square is 4 times of 9. 9 square is 81. Because 18 is 2 times of 9. So after the square operation, 324 is 4 times of 81. Here, square of 19, 361. In the Go game, which is popular in East Asia, which is the AI boost game. Okay, AI win the best player of Go game. Okay, so AI boost. The Go game board is 19 times 19. So this number 361 is the basic number of this game. 19 is the end of India's country commanding. Okay. Here, obviously, 400. Here, 441. In the same reason, square of 22 is 4 times of this. 4 times of 11th square. 484. This number, you must use your memory. Be familiar with them. 529. This is 4 times of this. And this number is very close to 600. 576. Yeah. 35. 25 square are in the same category of 50s. The answer is 625. 625 is important too because it means 4, 5 times together. 5 powered by 4. We will study it deeper a little later in this session. Okay. 2's power and 5's power, they are very important. Why? I will explain it later. Okay? This one is 4 times of this one. The number is 676. For the same reason, the square of 27, 729. on the key standpoint in the number system is important and essential too. Why? It means three lines times together, 9 power 3, or 6 3 multiple together, okay, times together, okay. Okay, this number is 4 times this number. How to calculate it cleverly? See it as 200. 200 times 4, 800. 800 minus 16. 4 times 4, 4 squared is 16. 800 minus 16. 784. Remember this one and this one. This is 841. Easy. About 30 square. Remember this one. Yeah, it's the largest one, less than 1000 in the field of square number. But why we list the square of 32? A little bigger than 1000 because it is so important in computer science, in computer usage. That means 1K when you use your computer. 1K is not exactly equals to 1000. 1K means this number. The computer construct on the base of binary, on the base of 2, on the base of positive and negative. Okay, and this number is 10. 10 twos multiple together, times together. 2 power 10. Okay? And just a little big than 1000. And its name in computer science is 1K. It's K. So you will know 1M equals to 1K squared equals to 22 times times together. Okay. And 1G. Multiply this number one more time. This number times 3 times. Okay. Multiple operation 3 times. Is nearly equal to 1000. 310 times together. So here is nearly but bigger than 1 million. Nearly equal to 1 billion, etc. Today, the requirement for storage for digital is bigger and bigger and bigger. The magnitude increase. They all based on this number. So it's very important. And it's just a little bigger than 1000. And this one is the biggest one within 1000 on square number field, on square number world. Be very familiar with this table. Just like meteor, dear old friend. Okay? The first issue. Basic square number. Then the second issue. Just now we mentioned that the whole human race is used the decimal system in daily life, in scientific research, in engineer or merchant operation. So naturally, 2 and 5 see them as a pair is very basic perspective. Because all our number is decimal system. So 2 and 5 are a pair. Similarly, 4 and 25, because here is 2 2's. 2 2's times together, 2 power 2. Here is 5 power 2. Combine them in multiple operation forms 210. That means 100. Further, 8 and 125 is a pair. To combine to 3/10. Furthermore, 16 and 6 to 5, 625 is a pair too. Yeah, I write here in different form. Okay, to introduce you new forms about numbers handwriting. Okay, that is all because our human race use decimal system. Like the clever calculation on adding and subtracting, the last session, our calculation module, section 1. In the similar logic, a pair number, we connect them by a curve. Okay? So the answer is 1300. We got 30 units. 1 unit is 100. Okay. Here we got 21,000. 3 digits. 3 digits a comma. That is international standards, handwriting standards. Everybody who knows mathematics can read it and can easily find out what digits you have written. Okay. Here, connected pairs. 100. 10 is 1,000. 3 digits, a comma, separated by a comma. Then we use it further. How about this? Separate 4, because the 4 is a pair to 25. Okay, so separated 4 from 28. The remaining part is 7. Okay, 700. You can tell yourself times 25 equals to divided by 4. In this sentence, you omit uh, the next operation. Move move the decimal point to the right 2 places. But it doesn't matter. You just do it right. You just tell yourself times 25 equals to divided by 4. In the same reason, times 5 equals to divided by 2. 80. Okay, 80. Then move the decimal point right place. Times here, times 125 equals to divided by 8. Okay? In your heart, you know you should, multiple the remaining number 3, 1000, 1000 times. Okay? Scale them, 3 level. Okay? Under the reverse logic, multiple divided by 25 equals to multiple 4. Yeah, here 103. Separate 100 from 300. Okay? 4 is a pair to 25. So remaining 4. So you can tell yourself divided by 25 equals to times 4. Omit the last half sentence. Remove the decimal point left place to the left 2 place. So here times 4, 12. These 2 0 disappear. The decimal point move left 2 place. So here's 12. For the similar reason, divided by 125 equals to multiple 8. 8 times 8, 64. Okay. The decimal point move 3 place. Descale 3 level. Okay. A further application of this pair rules. Okay. How about 15? 15 calculation. 15 multiple calculation is very common. It's very appear frequent in mathematics. How to do it? See it as this. Times 10, nothing happened. Times 5 equals to calculate the half of this. So times 15 equals to some number itself. Add is itself's half of itself. So how to calculate it cleverly? 36 add its half. If you can calculate it mentally, you write down, yeah, 36, 8 is half, 18 equals to 54. Yeah, a zero. The decimal point move right place. Okay. If you can't do it mentally, write a little down, write a little vertical form. It's okay. This number at this number. Yeah. 54. Then write down 54 0. Here, the half of this number, yeah, is 61. So this number at itself half is 183. Yeah, right. More zero behind the 183. Here is very obviously is 111. His half is 111. Add together is 3330. Separated 3 digits by a comma. Here, yeah, 1 8 add 4. 4 is his half. It's 12. Yeah. More deeper and deeper to use the pair system because of our decimal counting systems, decimal number systems. Okay, so yeah, sometimes combine them together, sometimes decomposition from 10, 100, or 1000, 1000, decomposite them. Okay. Next, our issue 3. Yeah. Canceling out. Multiplication and division. There are two opposite options, just like addition and subtraction. Okay. In the same logic pattern, yeah, numbers must use to multiply and numbers will use to divide. They are on opposite sides. Okay. You can write down the multiply side, these two numbers. In division side, these two number too. For reduce the scale of numeric calculation. Reduce the scale. The cancel out action should do first, just like we have done in clever calculation in on addition and subtraction. Cancel out first. Okay. In future, we can call it numerator. Can call this side denominator. Here now, we just understand that there are opposite sides is enough. Then cancel out. It's very easy. It's not 0, it's 1. 1 is the basic unit in multiplication and division. 0 0 is the basic uh, uh, basic element on addition and subtraction. Okay? Yeah. If you are not very proficient in do this thing, you can write the vertical form. Because vertical form can use the two-dimension paper efficiently. Okay. But you are very familiar with, after you are very familiar with this form, you can casing off. Do casing off option directly on the horizontal form, one dimension. It's okay. On the background of your prophecy, of your familiar level. Okay? It's one. I will do it later, or in the form of horizontal form. Okay? Yeah, 7 and 7 cancel out. This one cancel out this one equals to 4. Okay. These two number in division side. These two number is in multiplication side. Okay, so they cancel out. According to multiplication table, the cancel out result is 6. Here is 6 too. 6, 6. Square of 6. Yeah. This is about unwrapping parentheses. In the same logical pattern on addition and subtraction are wrapping parentheses. If the division signal appear in front of the parentheses, the symbols are all changed, are all reversed. So yeah, real sentences here. So only 38 in the division part. Other three numbers are in the multiplication side. Okay? 20. 2 and 0. And this one is a pair. 1,000 and more 0 is 10,000. 10,000. The whole number. 200,000. 3 digits, a comma. It's very important. Too many zero writing down together, the reader sometimes can miscounting your the number of zero, the number of the same number you write down. The reader may counting wrongly. To avoid this situation, yeah, 3 place a comma. Further application about this long chain. Because here are all division. So here 5, 7, 9 in the multiplication side, and 3, 5, 7 in the division side. In two groups, opposite groups, okay, with the separate line. After separate line, In the future, we will call it a numerator. Under the separate line, in the future, we will call it the denominator. Okay? What one can omit, one can ignore. Okay? 5, 7, 9, till 2, 39. This side, 3, 5, 7, till 2, 20, 37. We can write it down in abbreviation form. We can write here 5 till odds. 5 to 39 odds. Here is 3 to 37 odds 2. Cancel out. Erase the same part. The same part of these two groups is 5 to 7. 5 to 7 odd number is the same part of them. Yeah, erase them. 5 to 7. Only 39 remained. Yeah, here only 3 remained. Then cancel out these two numbers. Okay. The last one is a long chain. Control it. Control the whole number. Is the key capability. This problem testing you. Okay, testing you on this capability. You can write it down in two format, vertical format. But like teacher, like me, I have high capability. I can do it horizontal directly. Yeah. Let's show the difference of these two approach. In teacher's approach, 22. Erase these two numbers. 25. Erase, here is 5. Here is 5, but the remainder number is 2. 24. 6 and 4. 20, yeah. 27. Yeah. Actually, I cancel out 27 first because the only way to form 27 is 3 and 9. I remained in this number, the last. Okay, because a lot of way can form 24. So I do the only way to separate the number by division. First, the more way, waiting for a while, waiting to the last. Okay. Yeah, handle. So only these two number remember and remind. 56. 1, 1, 2. Okay. In the vertical form, a lot of work should be done. This operation signal, this operation form cannot writing down. Just write this 11 number. 1 is not necessary, so just write down the 10 number. And the opposite side, 4 number. 22, only way to form 22. Do it first. Yeah, 25, only way can form 25 by 2 times. Only this number and this number contain 5. This means 2 5. Here is 1 5, here is 1 5. Only these two numbers have 5. The remaining number is 2. If do 24 first, cancel out 22 first, you may use this 24 equals to 8. That's okay. But hand out this number have a more complicated, a little more complicated. How about 27? 3 here after cancelling out 3 and 6. So yeah, the division part all gone. Only left 2, 7, 2, 4. Okay, just like this. Okay, here is 8. I recommend this way, but need your capability. Okay, let's go into the fourth issue. Okay, it's about distributive law. When the multiple is close to the clean number, let the clean number as your benchmark. See it as 102. 100 add 2. Use distributive law. Here 1. This result is 48. 48,000 waiting for 48 times 2. Combine together. It's less than 100. Just write down the result in the 10 digits and the unit digits. It's enough. Okay. The benchmark of this, the clean number near to 99 is 100 minus 1. So this result using distributing law is 37 hundredths minus 37. If you have enough capability of mentally calculation, you can do it directly. 3, 6, 6, 3. If you have not, does not matter. Write it down in the vertical form. Okay? Yeah. That's okay. How about this? Yeah. Division operation. 1000 is clean number, is benchmark. Divided by 8. Yeah. The number paired to 8 is 125. 60 divided by 8 is 2. It's very clear. 127. Yeah, you have a lot of clever method on pair. Yeah, on pair, on clean number, on distributing law. You can do it very quickly. Yeah. Example number 9. Don't do it first as the problem teach you. A problem direct you. No. The number scale is large, it's too large. By the distribution law, do this division, the result is A. This division, the result is 11. Know how to reduce. Yeah, the calculation scale is very important. So it's 90.